The National Electrical Code, specifically Article 430.102 A, mandates that every motor exceeding 1/2 horsepower must be disconnected from all ungrounded conductors of the supply circuit. This requirement encompasses both the power conductors, commonly referred to as line conductors, and the neutral conductor. However, there exist exceptions to this fundamental rule. Firstly, an exception is granted when the motor is plugged into a receptacle that incorporates a built-in disconnecting mechanism. Such mechanisms may include fused receptacles or circuit breakers directly integrated into the receptacle design. Secondly, an exception arises when the motor is permanently wired to the supply circuit. In such cases, the absence of a plug and receptacle connection obviates the need for a separate disconnecting means at the point of connection. Unplugging a motor while it is actively running, that is, under load, presents significant safety hazards. The act of disconnecting a motor under load can generate arcing between the contacts in the plug and the receptacle as they are physically separated. This arcing phenomenon produces intense heat and light, which, in turn, can ignite flammable materials in the surrounding environment, thereby posing a fire risk. Furthermore, the arcing can inflict damage upon the motor windings themselves. The high-energy discharge can erode or compromise the insulation of the windings, leading to premature motor failure or reduced operational lifespan. Personnel in proximity to the arcing event may sustain burns or other injuries. The intense heat and radiation emitted during arcing can cause skin burns or eye damage, emphasizing the importance of safety precautions. Given the inherent dangers associated with unplugging a motor under load and the stipulations outlined in the NEC, such a practice is not considered safe or compliant with industry best practices. It is always advisable to de-energize the motor by disconnecting it from the power source prior to unplugging it from the receptacle. In facilities where motors are frequently connected and disconnected, it is recommended to install dedicated disconnecting means for each motor upstream of the plug connection. These disconnecting means may take the form of fuse switches or circuit breakers strategically positioned to provide a safe and convenient method for isolating the motor from the power supply. The installation of such disconnecting means enhances safety and ensures compliance with electrical codes. The National Electrical Code, or NEC, provides specific guidelines regarding disconnecting means for motors, addressing safety and operational requirements. The NEC mandates a disconnecting means capable of disconnecting the motor and all control equipment from all ungrounded supply conductors. This disconnecting means must be located within sight of the motor and the driven machinery location. This requirement ensures that the person performing maintenance or repair work has complete control over the power supply to prevent accidental energization. There are exceptions to the within-sight rule, but they involve specific conditions and procedures to ensure safety. The disconnecting means must be readily accessible. This means it should not be obstructed or require the use of tools to gain access, ensuring it can be quickly operated in case of an emergency. The NEC specifies the type and rating of the disconnecting means based on the motor's horsepower and voltage. Generally, it must be a switch or circuit breaker rated in horsepower and suitable for the motor's voltage and current. The disconnecting means must clearly indicate whether it is in the open or closed position. This visual indication helps prevent confusion and ensures that the circuit is indeed energized before work begins. For motors rated over 100 horsepower, the NEC allows for the use of a circuit breaker as the disconnecting means, provided it is readily accessible and can be locked in the open position. The disconnecting means should be lockable in the open position to comply with lockout/tag-up procedures. This prevents accidental re-energization during maintenance or repair. Disconnecting means must be suitable for the environmental conditions in the location where they are installed. For example, in a wet or corrosive environment, a NEC or forks-rated enclosure should be used. Article 430.109 of the NEC covers the different types of disconnects permitted for motors, based on horsepower. Small motors can often use horsepower-rated switches. Larger motors typically require circuit breakers or switches with specific interrupting ratings. The disconnecting means should be selected and installed in accordance with the manufacturer's instructions and any applicable listing or labeling requirements. Proper grounding and bonding of the disconnecting means are essential for electrical safety. The enclosure and all non-current carrying metal parts must be properly grounded to provide a path for fault current. Regular inspection and maintenance of the disconnecting means are necessary to ensure it functions properly. This includes checking for loose connections, corrosion, and any signs of damage. In summary, the NEC provides detailed requirements for disconnecting means for motors, emphasizing safety, accessibility, and proper selection and installation. Compliance with these requirements helps prevent electrical hazards and ensures the safe operation and maintenance of motor-driven equipment. Installing disconnecting means for motors before the plug, using a fuse switch or a circuit breaker, is a safety measure aligned with electrical standards. It helps to ensure safe disconnection under various operational conditions. The primary function of a fuse switch is to provide a means of disconnecting electrical circuits under load while also providing overcurrent protection. It combines the functionality of a switch, which can manually open and close a circuit, with fuses that protect the circuit from excessive current flow. A fuse switch typically consists of a metal enclosure housing a switch mechanism and one or more fuses. The switch mechanism allows the operator to manually open or close the circuit, while the fuses are designed to interrupt the circuit if the current exceeds a predetermined level. Fuse switches are available in various sizes and configurations to accommodate different voltage and current requirements. They are commonly used in industrial, commercial, and residential applications to protect electrical equipment and circuits from damage caused by overloads or short circuits. When selecting a fuse switch, it's important to consider the voltage and current ratings of the circuit, as well as the interrupting rating of the fuses. The interrupting rating is the maximum fault current that the fuse can safely interrupt without causing damage to the equipment or posing a safety hazard. Fuse switches should be installed and maintained by qualified electrical personnel in accordance with applicable electrical codes and standards. Proper installation and maintenance are essential for ensuring the safe and reliable operation of the fuse switch. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. All circuit breakers have common features in their mechanism. A circuit breaker typically consists of a set of contacts that are either closed or open, allowing or blocking the flow of current. These contacts are controlled by a mechanism that can trip the breaker in response to an overcurrent condition. When an overcurrent occurs, a sensing mechanism within the circuit breaker detects the fault. This sensing mechanism can be based on thermal, magnetic, or electronic principles. Once the fault is detected, the tripping mechanism is activated, causing the contacts to open and interrupt the flow of current. After the circuit breaker trips, it can be reset by manually moving the handle back to the on position, provided the fault has been cleared. Some circuit breakers are designed to automatically reset after a certain period. Circuit breakers are available in various types and sizes to suit different applications. Miniature circuit breakers, or MCBs, are commonly used in residential and light commercial applications to protect individual circuits. Molded case circuit breakers, or MCCBs, are used in higher current applications such as industrial and commercial distribution panels. Air circuit breakers, or ACPs, are used in high voltage applications to protect critical equipment and infrastructure. When selecting a circuit breaker, it's important to consider the voltage and current ratings of the circuit, as well as the interrupting rating of the breaker. The interrupting rating is the maximum fault current that the breaker can safely interrupt without causing damage to the equipment or posing a safety hazard. Circuit breakers should be installed and maintained by qualified electrical personnel in accordance with applicable electrical codes and standards. Proper installation and maintenance are essential for ensuring the safe and reliable operation of the circuit breaker. Consider the specific requirements of the application and the environment in which the disconnecting means will be used. Factors such as voltage, current, horsepower, environmental conditions, and safety requirements should all be taken into account when selecting a disconnecting means. Consulting with a qualified electrician or electrical engineer can help ensure that the selected disconnecting means is appropriate for the specific application and meets all applicable codes and standards. The most important part of electrical work is safety. Be sure to consult a qualified electrician and follow all applicable electrical codes and regulations.